Hello chemistry fans, and welcome back to Chemistry 1032 problem solving session here at the Academic Success Center on Broward College North Campus. I am your host, Dr. Russell Betts, and I'll be guiding you through this problem today. So without any further ado, let's take a look. Alright, let's read the question together carefully. A container is filled with 12 liters of N2 gas. The temperature of the gas is 22.3 degrees Celsius. The temperature of the gas is increased to 234 degrees Celsius. What is the new volume of the container if the pressure and the amount of gas remain the same? Wow, okay, so we have some gas in a container of some kind of container that can increase its volume with heat. And we're going to heat it up a lot, actually. So, wow, okay. Well, this kind of question, the best thing you can do, because there's a lot going on up here. There's a lot of words. You can lose some detail in these in the many words that are written here. So simply, let's write a little table, little list of what we got. All right, so we got a volume, 12 liters. So VI equals 12 liters of nitrogen gas. The temperature of the gas, so TI, equals 22.3 degrees Celsius. All right. The temperature of the gas is increased. So TF equals 234 degrees Celsius. What is the new volume? All right. VF equals question mark milliliters. Okay. So that's all the pertinent information. We have a volume of gas. We have a temperature, at room temperature more or less, a little bit higher. And we're going to increase the temperature dramatically, so the volume should go up, because this is a Charles's law question. Charles's law says that the volume and the temperature of a gas are proportional if the pressure and the amount of gas stays the same. So what does that mean? That means if you increase the temperature of a gas, its volume will go up. That means if you decrease the volume of a gas, the temperature will go down. Okay? So in my class, I will give you the formula. It is Ti over Vi equals Tf over Vf. Or you can take this formula and simply invert it. Put the V's on the top, the T's on the bottom. Vi over Ti equals Vf over Tf. All I did was I took the formula and I pancaked it, flipped it over, put the V's on top and the T's on the bottom. Both are correct. So now, I want to solve for Vf. So I'll put a little red square around Vf to remind myself that that's what I need to solve for. So I need to isolate it in this formula. And to do that, you simply multiply both sides by Vf. Oh, I'm sorry. TF, pardon me. We all make mistakes. Pardon me, that should be TF. So let me rewrite this over here. I'm sorry about that. Made a little error. Let me correct it real quick. There we go. So I want to solve for Vf. So then I'm going to multiply both sides by Tf, because I want to get Vf on all by himself. Now that mistake, I caught it early, but I would have caught it later because I would have put my units in. By putting the units in, I would have caught that just simply because the units wouldn't have worked. I would have had a weird unit at the end, so I would have known I had a major problem. All right, so Vi multiplied by Tf, all divided by Ti. All right, so now, the next thing you have to do in these kinds of questions is convert the temperatures to Kelvin if they're not already in Kelvin. So here we have temperatures in degrees Celsius, so we're going to just convert these things right quick to Kelvin by adding 273. Alrighty. 22.3 plus 273 equals 295. And 234 plus 273 is 507 Kelvin. Okay, so now the reason we do that is mathematical, first of all, and it is appropriate to do so. What if we started out our Ti at 0 degrees Celsius? Then at the end, our Ti would be 0. We'd be dividing by a 0, which is not allowed. You'd have a 0 volume. Or worse, what if Ti or Tf was negative? Then we would have a negative volume, and that's not allowed. You can't have a negative volume. So we have to convert everything to Kelvin, because the Kelvin scale never falls below 0. That's why we do it. Okay, so let's plug in some numbers. Vf. So we need Vi, so 12 liters, multiplied by Tf, which is 507 Kelvin. All that now is divided by Ti, which is 295 Kelvin. Okay, now make sure the units cancel to leave you in a volume unit. Left in liters. So that's good. That's the unit we want. Now, before we do any number crunching, let's see what kind of logic we should see. We have 12 liters of gas. We've increased it dramatically, so the volume should go up. Should go up quite a bit, actually. So if the number at the end we get is less than 12, I know I've made an error somewhere in here. So let's check the number. Let's make sure it makes logical sense. So 12 multiplied by 507 divided by 295. Oh, I got 295 again. Let me make sure I didn't just make a mistake there. There it is. 20.6 or 21 liters. So the volume of this container almost doubled. Okay? Which is a good thing. We should have had a higher volume because we increased the temperature of the gas so much. Okay? So I hope that this was okay. I hope that it was helpful. If you still have problems with this question, please do not hesitate to contact one of the tutors here at the Academic Success Center, or come on by your professor's office hours to see, to get this kind of question straight. Please don't leave it sitting. It's really not a hard question. It's really kind of easy once you get the hang of them, but you do have to practice. And with that, I wish you good luck and good chemistry.